So you're thinking about the 2x as 2x over 1, of course, right? So you could combine these. And I'm gonna change that 8 from an 8, sorry, to a 16. You put it together, you made the common denominator x squared, and on top is 2x cubed plus 16, yes?
Yes.
Okay, start graphing it, let's see what you can do. I think I changed it. I change it to an 8 and then a 16. Go ahead and check it with the neighbor, make sure that it's saying things that you're doing. Acting. They're coming together, it's a little different, right? It's kind of something's a little funky here. Ready to start talking about it?
Not quite.
No, almost.
I think it is about.
I'll give you another 15 seconds. I know it's generous. Okay. Ready or not, let's start talking about this. Before I do, I forgot to mention last time how nice it was to meet your parents. The parents who came here, they're well behaved and generally well mannered. So nicely done. Rohan, you've been called, and I have a question for you. Before even graphing, like just looking at this, what makes you think you know about the graph?
It's vertical class instead of 0.
Okay, vertical asymptote at 0. And when you say it's 0, is just the number is 0, or is it an equation? X equals 0. Okay.
It's top heavy, therefore I'll have a big graphical.
Okay. Do we agree with these things so far? Okay. And did you? And,
Yeah, therefore you're gonna go divide into more division.
okay.
And I got y equals 4.
Okay. So when you did the long division, did it look something like this? 2x cubed plus 0x squared, etc.
Yep.
Okay. And you got. Did you get a remainder, or you just got to 2x and then you're done?
I did get a minute, but I just made that y equals 2.
Okay, that's all we need. Good. Any questions so far? Okay, that means no questions. I do want to give you a little bit of a tip here. As you know, the a plus b, so a over b plus c over b is equal to a plus c over b. So we could go from left to right or from right to left. So if you're given something like a plus c over b, you could separate that. I hope it makes sense into a over b plus c over b. Does that make sense? I call that process pulling a Moses. Yes. If anyone who knows anything about the Bible, Moses split the Red Sea. So we're splitting I'm talking about it as a literary work, by the way. We're just splitting that fraction. So we could do the same thing here. We could just say that this is equal to 2x cubed over x squared plus 16 over x squared, which is kind of nice, isn't it? Because we see that we actually arrive right back where we started. So we didn't actually have to do division to realize, oh, we started dividing towards originally, but it's a nice way to confirm that it's all equivalent. Okay, so I'm going to go ahead and put these up here. Chazzy shared with me something. Do you mind if I share your? He puts his dash line just off the axis so you can actually see it, and then he just labels it so we know exactly what it is. But that way it doesn't fade into oblivion. I think it's not a terrible idea as long as you are mindful about it. I don't care about that. Rohan, did you find out anything else about this graph? Like anything easy?
So there is no y-intercept.
Okay. None. Okay.
That's the undefined. And then for my x-intercept, I got -2.
Are we good with that? Do you see why I changed that 16? Just to get a clean answer there. Okay, so let's put this together. I'm going to put the -2 pretty close to that origin. But do you see what happens on this side with the graph? There's only one thing you can do. This is going towards asymptotes. Go up this way. And then. Oh, this is difficult. This is a difficult curve to draw. But I'll make it happen. There we go. Are we good with that? On the other side, have you already thought about what it looks like? On the whiteboard in front of you, just take your finger marker and show me what it looks like. It's either up here or down here, and we know that it has to be cut in the corner of it. Because otherwise it would introduce yet another x-intersection. It just doesn't exist. Are we done? Oh, this is graphic function. You should be able to use limits, and limit as x goes to infinity would be equal to as x goes to infinity. Infinity as x goes to negative infinity. Down. Any questions? I like to point out that there's a feature on here that we haven't really gone over in this class. Multiplicity. You see how multiplicity plays out in this case? Discuss with your neighbor how, what am I talking about? How does it play out in this graph? Yes.
One question, like,
yeah, I think that's what I was talking about. Yeah, it's a little belated.
So we should know that.
Yeah. Okay, so do you figure it out? Okay, Rhonda, do you mind sharing? I heard a little bit of what you were saying. I really like what you were saying.
Okay, I know this isn't correct in some terms, but these things, I think the values of that, like the values of the asymptote, and so 0 is being squared, so I think even multiplicity, so I guess the limit of the, I don't know how to explain it, but like the arrow should be going, either both be going in a plus.
Wait, say that one more time, because that's what.
So, because you're asking the arrows.
Are we good with that? Nice. Yeah.
It's just that, so it's just this.
We're not too concerned with the oblique, although that'd be interesting to consider. But yeah, that vertical asymptote does have frequency too, so the behavior will be the same on either side. Just like when you have that polynomial, if you have a even multiplicity here, it's not just a touch, but it's going to be either positive or negative to negative. So it's the same kind of thing with positive infinity, positive infinity. The feature that we see here is called kind of smooth. I've never heard of it. Balancing out infinity. I saw it's impossible to bounce off infinity, but it goes up and then it comes back. Or bounce off. Have we seen that before? Have we seen that same behavior on either side of the vertical asymptotes? Because all the problems we've done have been this, right? Left, it's different than right. Haven't they all been that? Except for one. Maybe on your homework, maybe. Yeah, so but also 1 over x squared. Do you remember what this looks like? Right, this is right, it's this and this, right? It's that bouncing off infinity idea. That's gonna happen anytime there's multiplicity of an even number. Yeah, okay. Oh, does it cross that oblique asymptote?
No.
Are you sure? How do you know? You said it equal, so I would set the original function equal to 2x. I hope you make sense of- There's no value of x that would make that true. Right, 2x plus something equal to 2x. No, it's not gonna work. Okay, we're moving on. I think that's our last graphing problem. Now. We give you the graph. Before you do anything, I'd like you to just discuss with your neighbor, what do you need to make sure is in the ingredients for this graph? Discuss, please.
Yeah. Why? We're going to have to do next week. And then we're going to actually go later on. We have to do
Whenever you're ready, start building the function.
Yeah, I can't over anything crossing with.
It's a error. This is the touch at one.
And zero or just
Yeah.
Just one, and then it goes through.
What are the intersections?
zero and eight, one. Three. No, why? One. Something we don't know. The line step is not zero. No. Looks like it. Yeah.
It looks like it might be, but we're going to be the line girls.
Oh, it's cool.
So it's not the, it doesn't go through the board.
Wait, so how did you? Put something gold on the line?
It goes by axis, so that.
I think it's cool. You don't need to point to the point. Why? Right, so it's about like 1.5. That's what. Oh. You're not wrong, it's a little bit. Right. Yeah. I mean, so why don't we yeah, why? We ready?
Well, that's why you got Noah there. That'll help you out of that hole.
Once you find out. who caused the red So you're-
30 seconds and I'll,
So
well, the universe will call one lucky victim person.
So.
That means the one out wide. I can see. Like, very solid.
Yes, it's not-
Okay, so you've had time to discuss, had time to work. If I could get everyone's attention, if I could get everyone's attention, we'll work all this out. So. Hudson, what are some things that are important to notice about this that we need to include in our function? Just a minute, guys, please. So we're passing to where? Okay,
Then there is a horizontal aspect of y equals to, which means that the exponent of the numerator and denominator can be the same.
so I was gonna try to write that down, but it's a lot, but yeah, perfect, okay. And anything else? Thanks. You wanna start putting this together in the function? Yeah, let's. Are we good with this so far? Anything else or this? Very, very nice. It's really, really good. Nolan, do you have a suggestion? Are we good with that? Has that touch rate, just like Ronald has got that. That kind of messes things up, doesn't it? I have third degree on the top. But no, we want to continue. It's not, it's both sides. So. Was there anything else? Anyone? Was there anything else? Rohan?
No, I have nothing else, but I have a question. And so when it is going to for X before, like that means it can't be X bar, like. Yeah, I know, but
Oh yeah, it could be some fourth power.
I could be like 6 hours.
Generally, we keep it at the plus. Any other questions? Oh, that'd be interesting. I've noticed that the point isn't really highlighted. So I'm gonna say let's just trust that it'll do it, but especially definitely within graphing, I would look for something like that. But I think we're good enough to say, yeah, we nailed it. So thank you for your help. Any final questions before we move on? Yes. Yeah. Thank you. Yeah, please don't go multiplying stuff out. Yeah, that you leave yourself open to mistakes and you're complicating the view of just being able to see all the information right there. Of course, if it starts in standard or standard, then factor it, but leave it just like that. This is a good one. I'm so jealous of you seeing this one for the first time. Have fun. Sure, if you haven't, like, you're checking in with your neighbor. All right.
Getting it? Yeah. Where is this? Well, let's see. Yeah, sometimes maybe the hints are hurtful. It's on it and then put back on. So I'd like to know, this, what are some things
That you noticed about it, and then I'll give you the option of moving on with the function. Sophia,
Yeah.
so let's listen to Sophia, gentlemen. So what did you notice that was gonna have to be included in the graph or function?
For asymptotes, x equals -1 and x equals 2. So you can put those on the bottom of the function.
Okay,
So I have x plus 1 squared and x minus 2 squared,
and you square them because,
because they both are going either in the infinity direction or the negative direction on both sides.
are we perfectly clear on that? That's definitely something I need to see. If this is a question on the test, I need to see that multiplicity of 2, please. Continue.
And then on the top, I have x minus 1 and x minus 3 because the x intersect is 1 and 3. That's fine.
Okay, this is good stuff, isn't it? Of course, let's not forget now, you probably wrote it on yours, but let's not forget that we always need that first part, f of x equals. Without it, I'm gonna ding you because we need inputs and outputs. So, but we were focused on just building that there. So one thing that's missing right now is the horizontal asymptote, right? The horizontal asymptote is missing. And we really can't change the bottom, can we? The bottom is kind of stuck in place. Yes,
You're gonna make x minus 1 the power of 3 because you can see on the graph that it goes to as of the.
Alright, so we need 4 up here. We can't introduce any more zeros because there aren't any more.
would it make sense to put a cube on there? Are we good with that? No, I'm not saying it's right, but I'm not saying it's right. But would it make sense to do that?
Yeah.
I think that makes perfect sense. But what's the problem? This y-intercept. It looks like they're pretty purposeful about a specific y-intercept, weren't they, when creating this graph? Like the last one, it looks like they couldn't care less where it landed. But here, it looks like the y-intercept should be 1.
So let's check. We check that y-intercept by checking f of 0. Okay, so that gives us -1 times -3 over 1 times 4, which is equal to not 1. 3/4. So maybe it's 3/4. Maybe it is pretty close to 1. Could that be 3/4? Really?
Yeah, it does.
You think that might be 3/4?
That's for sure.
Maybe that's 0.99.
We can't assume anything from the graph.
Oh, kind of super.
That graph, 0.1.
0.1. But you're right, and if this were on a test that's unclear, make sure that you're checking, is this what I think it is? And we do want that to be 0.1. That's only like.
It's on like the horizontal axis, which is probably.
So probably,
One.
oh, that's true, yeah. Yeah. So there's a vote that yes, it's 1. And I'm gonna tell you that yes, the y-intercept is 1. So in my other class, one of the suggestions was, well, we take this and just add a quarter to it. Then wouldn't that just kind of give us that y-intercept of 1? That gives the y-intercept. What does that mess up though? Everything else. Well, the vertical asymptote, so it's okay, but we lose the zeros, don't we? You can't use ZPP when you're adding to something, so whereas we could have before this, I'd say that this is a better guess, and I would actually say that this is a really good A- guess. It's a really solid guess, and I would not take any. I take a little bit away if you did this. The problem is that the cubic would look a little bit more like twisty at that point. A little twisty at the point here. It's kind of twistish, but it's going through nicely. More like this. I think going through That's more than I like. Squash. So the hint, how do you, because including that three was a good way of increasing the degree without increasing the number of zeros, but there's got to be another way. How to increase the degree of a polynomial without increasing the number of zeros? There might be some imaginary zeros, right? But how would you introduce imaginary zeros? Dun, dun, dun. What's that? What do you mean?
Like if you have the x minus one, do just be like.
So you're introducing maybe some of or a difference of cubes, with one of the factors being x minus one, and the rest would be imaginary. Oh, I like that. I like that. I'm not going to pursue that, but I would show my colleagues if anyone did that to show them how impressed I am with any student who went down that road. I do something a little bit simpler if you don't mind. I'm going to introduce another factor here. Inside the factor, it's going to be, there won't be an I in there. What degree do I want on top? I want fourth degree. So how about I put x squared plus something. Right, notice the zeros don't change, do they? And if a is positive, I now have two imaginary zeros, don't I?
Yeah.
Right, if a is positive, I'm gonna have two imaginary zeros. If this is a 1 or a 3 or 11, I'm gonna have two imaginary zeros. So I haven't added anything. I haven't met the other zeros. Brandon, you have a question?
Yeah, I don't have it.
Okay, I understand that. Oh, yeah.
What is not, you must, the, y, right, that, it doesn't have to be one then?
We have to figure out what A is. Now, this is temporary, arbitrary constant. How do we figure out what A is?
Give them a line,
Either way.
Let's
Let's work it out. I think the A is up here, isn't it? So this time I put 0 again. Now that we have this. Set that equals to 1. So for A, I think you can do it. 3/4 A equals 1. Equals 4/3. So my equation, I'm not going to write that whole thing again. I'm just going to have that A out of there and put a 4/3. So notice the zeros remain. Should we check the y-intercept? It's good. Okay, well, I'll check it. Yeah, if you plug in zeros, you do that. Output is 1. Was that a nice twist? Which cubic?
We're having, we have.
No, so
the cubic
it's
before,
not
that's
like-
why I said-
We do cubic, we don't get that line, so we still have the correct x in the set. That's not a cubic. If it looks more like a squash, like here, and then. What is it really obvious? It's much more.
How do you know that it's like, is it actually the didn't say about the children as long as it's gonna be a person on common? Like the errors on the computer?
At this point, I think just putting our pieces together, the fact we have x intercept here, and have it sort of put and force into place here. And then because it's an effect, what they do, kind of falls into that order. I'm not sure that answers the question.
Yeah, because I guess you didn't know that I was kind of reasoning it, but like, there's a way to find out even like past reading. I can do it.
I wouldn't, because within the asymptote. I just want to use the left of that asymptote, right? We're gonna just put the piece that we know, the easy pieces, and put those together. quickly. We can definitely do if you want. I'm not gonna hold it against you. But I might cut the time before you finish. Okay, so the rest of today, you have time to work on the assignment. In class. Oh, and I'm gonna give you a quiz back. Thank you.
Bro, I got that 99 and I was like, I can't. Yeah, I don't need it. I went to do what I know. That's crazy. Yeah. That's crazy.
Wait, no, I-
It's, you know, like,
I'm not
I'm
thinking pretty.
Sorry. Yeah, well. What? They both are, they're right. Don't worry about it. Oh, no. I really not have time to do that, Why does it use it? Yeah, you think it's funny, you want.